Circle theorems. I'm going to look at the grade B circle theorems. First of all, I'm going to do a recap. If you do want to go straight to the questions to practice, because you already know the rules, then you can just click on these question numbers here on the YouTube links and it should take you straight there. Or if you go into the comment section below, I will post the links there so you can go straight to the questions. To start with, we're just going to recap on the rules that we should know about circles. Okay, so I've got them started here. So the first one, angles formed formed from a chord are always equal in the same segment. Now a lot of these rules are quite sort of wordy, but essentially they're very basic things. So if I create an angle from this chord, so that angle there formed from that chord, that angle there is the same wherever you draw it. So if I draw it another angle over here from the same chord, so it's coming up from that same line that's going across the circle, which is a chord, is the same as that angle. And if I draw another one, as long as it's on this side of the line, they're all on the same side, or they could be on the other side of the line, but they do have to be on the same side. So if I draw another one over here somewhere, then that is also equal. So all those are the same angle. If we call it A, they would all be A. So whenever you're given one angle and then you see another one formed from the same chord, then those angles are the same. Okay, so that's one of the major rules used a lot of the time. Another one that's used a lot of the time is the angle formed from a chord at the center. So if we look at the angle formed at the center from this chord, so that angle there at the center, that angle is going to be twice the angle formed on the circumference. So it doesn't matter where on the circumference, because we can use the first rule to draw this anywhere. It's always the same. This angle doesn't matter where it's drawn. It could be drawn over here or over there. It's always the same. This angle on the circumference, if that's A, then this angle at the center is 2A. So the one at the center is twice the one circumference. Now I'll just draw an example of this rule, because sometimes it gets a bit awkward to see this rule, because if it's drawn over to the side like this, over on this side, they sort of cross over and it looks a bit awkward. But imagine just dragging that around so that it's above there, and you should be able to see that it's the same rule. Okay, another one. This is actually a resultant of this rule. Just if you stretch out this chord, so it's actually a diameter, so the angle formed at the center, which is actually just this line, which is 180 degrees, so this angle here around the center is twice the one formed on the circumference. So if we draw an angle on the circumference from here, this one at the center is twice this one at the circumference. So that makes, because this is 180, that makes this a right angle, 90 degrees. And again, using the first rule, it doesn't matter where we draw that angle on the circumference from this chord, which is actually the diameter, you always get a 90 degree angle. So the angle formed in a semicircle, so from the diameter to any part of the semicircle, even on the bottom side, the triangle formed is a right angle triangle. So this angle is always 90. And the fourth rule that we're going to look at is to do with cyclic quadrilateral. So any four-sided shape drawn so that the points are all on the circumference of the circle, so all 4 points. In that case, we have a rule that says that the opposite tells us that the opposite angles are indeed equal. So let's actually just draw that in with a green line. So these two angles here, this angle and this angle, sorry, not equal, did I say equal? They add up to 180. So those two add to make 180. So if this one was 100, this one would be 80. And similarly, the other two angles, let's do them in red, these two angles across here from each other, they also add up to 180. So if this angle here was 60, then this one over here would have to be 120. So those opposite angles when you've got a four-sided shape on a circumference of a circle added to 180. Okay, just two more rules we need to look at, and these are to do with tangents. The first one is a fairly basic. It's actually the definition of a tangent, or part of the definition of a tangent, is that the angle formed between a tangent and the radius of a circle is 90 degrees. So tangents to a circle at right angles to the radius. And the other one is if we have two lines, two tangents to a circle, then this part of the line, this from here to where they cross, and from there to there, those are the same distances. If that was x, this would also be x. So we can mark that line there and that line there with a similar, with a mark like that to show that they are the same. And also, as this is a tangent, this angle in here, not this angle, but this line here and this line here are both radiuses by definition of a tangent. So those two are the same because they're radiuses, and that must make this 90 degrees and this 90 degrees, and therefore we have this shape that's formed here is a kite. And because those two are 90 degrees, these two angles, because all the angles in a four-sided shape, quadrilateral, add up to 360, these opposite two must be adding to 180, just like we did in a cyclic quadrilateral. But this is when we've got two tangents crossing. So lots of little rules we can get from that can help us to work out shapes to do with tangents. And quite often one is when you have a line going across the shape here, then we know this is an isosceles triangle because these two are the same. So if we can know this angle, we can work out this angle, we can work out those angles by just applying some basic rules of angles. Okay, so we're going to move on to question 1. Okay, this is just a standard, see the rule, work out the answer. So have a go at this. Okay, the first one, we're actually told this is 90 degrees, so this is using the rule where the angle at circumference is half the one at the centre. So if that's 90 degrees, then this must be 45 degrees because it's half. So we could write, sometimes they ask you to explain, so you would say the angle at the circumference is half the angle at the centre, or the angle at the centre is twice the one at the circumference. In B, we've got these angles formed from a chord. Angles formed on the circumference of a circle from a chord and in the same segment are equal, so that's just going to be 53. So those two are equal. Here we have the triangle formed in a semicircle. Because this is a diameter, this angle is going to be 90 degrees. Based on this rule again, the 180 degrees here, so the angle formed from it is going to be half the 180, which is 90. And here we have a cyclic quadrilateral. All the sides, all the vertices are on the circumference of the circle, so that makes opposite angles add up to 180, so D is going to be 80. And when you're just stating the reason, you just got to explain that rule for each one. Okay, another question. Have a go at this one. Okay, we've got lots of words telling us stuff about this, but we can see this straight away. We've got a chord here, two angles formed from the chord, and they must be equal. So we write that down. Angles formed on the circumference from a chord are equal. Could add a little bit on there in the same segment. That just means on the same side. If it was formed on the other side, it wouldn't be equal, but if they're formed on the same side, then they're equal. Next one. Okay, have a little go at this one. Okay, here we have a diameter. So these triangles formed in the semicircles because this is the diameter. So this triangle on this side is right angled, and this triangle on this side is right angled. And also we're shown that this whole shape is a cyclic quadrilateral. But anyway, let's just use this angle. Tells us these two make 111, also 110. So this is going to be 70. And if that's 70, okay, then because this is a kite, it says here it's a kite. So that means this is a line of symmetry coming down the middle here. Therefore x must be 70 as well. Next one. Okay, here we have a cyclic trapezium. So that's a quadrilateral that's cyclic, so it's touching the circumference of the circle. It's also trapezium, which means it's got one pair of lines, one pair of parallel lines. So this first question, x, is actually not to do with circle theorems. It's just these parallel lines in a trapezium. This shape here, let's just draw it in. This shape here, where the angles are on the interior of the parallel lines, line crossing the parallel lines, they must add up to 180 because they're what we call interior angles. Sometimes they call them supplementary angles, but the angle there is going to be 180 minus 75, which is 105. And the reason being that they are interior angles. I think the key word there is interior angles, where a line crosses parallel lines. Work out the value of y, give a reason for your answer. So this angle here, y, once we know this is 105 and we know this is a cyclic quadrilateral, then we know opposite angles add up to 180, so we put 180 minus 105, which is 75 again. Opposite angles in a cyclic quadrilateral add up to 180 degrees. And work out the value of z. Well, we could have done that using the same rule. They're opposite cyclic quadrilateral, so z is going to be 180, take away 75, which is 105. It's only worth 1 mark for this one, so the actual answer itself is only worth 1 mark, so you don't really need to show any working, because if you get it wrong, you get it wrong. But always worth writing your working down for anything, any calculation you do. Okay, here we have a question. A, B, C, D, points on the circumference, so that tells us that it's a cyclic quadrilateral again. We are told the angle is 130 here, and we've got this shape here, where the angle formed at the centre is twice the angle formed on the circumference. So the angle x is going to be a half of 130, which is going to be 65, because the angle formed on the circumference is half the angle at the centre. Calculate the value of y, give a reason for your answer. So this y value here, it might be tempting to think this is a cyclic quadrilateral, but this isn't on the circumference, but x is on the circumference, so this whole shape is a cyclic quadrilateral. So those opposite angles there, x and y, they add up to 180. So y is going to be 180 minus 65, which is 115. Tidy that up a little bit, 180 minus 65. And the reason why opposite angles in a cyclic quadrilateral add to 180 degrees. Okay, next one. That's a slightly unusual question. Have a little think about this one. Okay, we're told we've got tangents to the circle, so these lines here are tangents, and we know with tangents cross that the distance from the point where they touch the circle to where they cross is the same. That makes these isosceles triangles. So this one is the same as this one, and these two are the same as these. These two are the same. So we're going to write down the length for CD. From C to D is going to be the same as C to E, so that's going to be 4 centimeters. And the perimeter of the triangle is 32, calculate length of DB, so the whole triangle is 32. We know that's 4, that's 4, that's 5, that's 5. So that tells us we've got 4 and 4 plus 4 plus 5 plus 5, and we call this x. It's the same for both. Plus 2 lots of x, so we've got x plus x. That's equal to 32. So we've got 9 and 10 is 19. Plus 2x is 32. So 2x is going to be equal to 32 take away. Sorry, not 19. What am I talking about? That's 18, isn't it? Let's get it right. 4 and 4 is 8, not 9. So 2x is going to be 14. Because 32 take away 18 is 14. So x is going to be 7 centimeters. So the missing, oh, that's not the actual answer though, is it? Notice it is D to B, 7 centimeters, this distance here, which is x. Okay, next one. Okay, so write down the value of x, give a reason for your answer. So if we're just writing it down, we should just be able to say what it is. Again, we have parallel lines, so we can use a parallel line rule here. This shape here formed by the parallel lines, these two angles are the same. Now this we used to be able to call this just the Z rule for parallel lines, but most exam boards want you to write the technical name for this, which is alternate angles. So x and 37 are the same, so it's 37 degrees. Alternate angles are equal. I could write a big long spiel about it being alternate angles where a line crosses parallel lines, but as long as you've got the word alternate, you're going to get the mark there. Work out the value of y. Because this is a cyclic quadrilateral, just as before, those are going to add up to 180. So y is going to be 180 minus 79, which is 101 degrees. And because that's 2 marks, it's very important you write that sort of thing down. It doesn't actually ask for a reason, but there we go. Now last question. Okay, in the diagram, AB is the diameter. Work out the value of x. Well, we know from earlier that any triangle formed in a semicircle, so from the diameter, is 90 degrees. So this angle in here is 90 degrees. So that allows us to look at this big triangle ABC, and we know that this angle here is going to be 180 minus 90 minus 23, that's the whole angle there, which is going to be 90 take away 23, which is 67. And then we can just look at this triangle that we're left, which we want to find x, so 36 plus 67 plus x equals 180. So we add those together, we get 90, 103 plus x is 180. So x equals 180 take away 3, which is 77. 77 degrees, 3 marks. Okay, so lots of questions on circle theorems. These are all grade B questions. There are harder ones that you can look up on on YouTube from me or from other people. Mainly the alternate segment theorem, which takes questions up into grade AA star. But these are the basic ones that you should be familiar with before you move on to those.